Hello children. Yes, in the last class we have seen concave mirror and the different types of images that can be formed depending on different locations of the object with respect to the concave mirror. And we also discussed about the experiment that can be performed, and then later on we continued with the ray diagrams. Let me recollect all those things, and just it can be a quick review for you that you can just give a glance in your mind, like about first case being like rough focal length you can determine, making the concave mirror facing the sun, and the image is a spotted image, or rather we call it as a diminished image, inverted, and real image is formed at the focus. As you are bringing the object nearer to the mirror, that is beyond C at a finite distance, you can see that the image is formed between focus and C, and that is a smaller size image, may not be diminished but smaller than the object size, but it is inverted and real. And then still further you are moving the object further closer to the mirror, and let us fix the object yet C. What is C? Center of curvature. At that point you can observe that even the image is formed at C, and the size of the image is as that of the object. That means what is happening, as the object is coming closer, the image is moving away from the mirror, as well as the size of the image is also increasing. So at F, when the image was formed at F, when image formed at F, it was diminished. Then between F and C, smaller in size, that means size is increased from diminished to a little bit finite value. And then again, when it has formed at C, it is equal to that of the image of size of the object. Then as you are making the object move furthermore closer to concave mirror, that is between F and C, if the object is, then the image is formed beyond C, which is magnified image. That means the size has much more increased, magnified, real and inverted image. And then now the object is yet F, the image is formed at infinity, where you can't see the image or you can't capture it on the screen because we cannot reach infinity. But by symmetry we say that it is formed at infinity. Why? Because see, two infinite lines meet at infinity. Two parallel lines meet at infinity. This is what we always learn, right? And similarly, and then afterwards, when the object is brought between the focus and pole of the mirror, the special case, that is the special case where you can see that the rays get diverged away. Usually concave mirror, all the rays converge. But here what is happening in this particular case? The rays are getting diverged away, therefore they seem to be coming from somewhere behind the mirror at a point. And there the virtual image is formed. There the virtual image is formed. Right? And at that moment we also discussed the point that here at this point of context, here this concave mirror is behaving as a convex mirror. And now let us see how to draw ray diagrams for convex mirror. The rules are the same. As we said, what are the rules that we have seen? Like the ray which is incident parallel to the principal axis. So let me take, this is the convex mirror. You can see that the reflecting surface is bulged outwards. This is the pole of the mirror. Focus C. Center of curvature, sorry. Right, this is F. F and then center of curvature C. See, what are the rules that we have discussed? The first rule is that when the ray is incident parallel to the principal axis, it is supposed to pass through focus in concave mirror. When it comes to convex mirror, see, the ray is incident parallel to the principal axis at this point. Right? Now it is convex, that will get diverged away. How will they seem to be diverged away? Like as though the ray is coming from the focus. Why? Because in case of concave mirror, we have seen that on reflection it passes through the focus. So not on reflection, it passes through focus. Here it is convex mirror. So the same rule here is it diverges away or it gets reflected from the mirror as though the ray is coming from the focus. The one which is parallel to the principal axis will have this behavior. And the second rule, suppose if a ray is incident in such a manner that means like this, it should reflect back parallel to principal axis. That means just if the ray started here, it retraces its path like this. It takes its path like this. That is the second rule. And the third one is whenever a ray is made to incident on the convex mirror, it gets reflected back in such a manner. That means in which direction we are incidenting here? In the direction of radius of curvature. That means through the optic center. Through the center of curvature. Through the center of curvature, if the ray is made to incident, right, then it reflects back along the same path that we have seen even in case of concave mirror. So here in convex mirror also we have the same rule. That means suppose if the ray is incident here, let us imagine that this is the ray is incident here. Okay, along the normal. Is it not? Along the normal. The normal always passes through center of curvature, or what we say is along the radius of curvature, right? And then it again reflects back in the same path in opposite direction. These are the three rules. First rule, parallel to principal axis, passes through focus. Second rule, when incident along the focal length, along the direction of the focus, then it gets reflected back parallel to the principal axis. Third rule, if it is made to incident normally, right, then it reflects back in the same path, along the same path, but in opposite direction. Okay, so this is what we have studied in case of concave mirror also. Now in case of convex mirror, these are the rules, like that. Here their concave mirror, it directly passes through focus. But here what we see is that it is reflecting back in such a manner that as though it is coming from focus. Right? So that's the only difference. Here always as though. It seems to be. Why? Because virtual, whatever the kind of image which is going to form is not real, it is virtual. The rays always get diverged away in different directions. Thus, there is no point that they will get converged at a point when a particular object, an illuminated object, is brought near to the convex mirror. Always a virtual image is formed. That case we will see now within few minutes. Now your job is just pause the video for a moment and note down these three rule condition diagram and then make the rules. Write the rules in your own words. Rule 1, rule 2 and rule 3. Okay children, so pause the video for a second and then please copy the diagram and give your conclusions for the rules 1, 2 and 3. Right? So please carry on with this. Right then. So now what is this? Now you have seen how the rules, means how we frame the rules based on the behavior of the light rays when they are made to incident on convex mirror. Now we are going to see the next ray diagram. We don't have so many cases as we have it in concave mirror. Concave mirror at different locations, when the object is at different locations, the image is also of different sizes, different kind of behavior and also at different locations. Here the thing is always the image is virtual image. and then erect image. So thus we, all the things together you can like just define like as one particular case. Now let us see that this is convex mirror. The reflecting surface is bulged outward. Passing through the pole is the principal axis. You have F and C. F and C. Now let us take an object. Let us take an object. Okay. So this is an illuminated object from which the light rays are falling on the mirror. So when you will be drawing with scale, it will be easy for you. So now parallel to principal axis, we are taking one particular ray. So it seems, it reflects back as though it is passing through the focus. As though it is passing through the focus. This is what the kind of thing is. And we shall take one more ray, right, which is passing through center of curvature, which is like as though it is like along the normal. So let me draw the dotted line from here. So which can touch this. Once when it is done, let me take my ray to be like this. Let me take the ray. So this is the other ray. A little bit confusing, is it not? Nothing to be worried. See, we are taking one ray which is parallel to the principal axis. If it is concave, the reflected ray would have passed like this. But this is convex. See how it is. The surface is different. Right? Therefore, it is getting reflected back like this. So, how should you draw this reflected ray? It should be drawn in such a manner that the ray is coming from F. Then, first rule is accepted. Means, you are like obeying the first rule, we do it. Now for right now we are not talking about the second one, but we went to the third one. What is the third one? When the ray is incident normally. When the ray is incident normally. What is meant by normal? A normal always passes through center of curvature. Always passes through center of curvature. So we are taking that particular ray like this. And here the ray is incident. Is it not? Here the ray is incident. It is not passing through this and going here. Children, this is reflection concept. There is no point of like the ray being penetrated inside. Okay. So here the ray is incident. Why this dotted ray? To help us like see where the normal is. Okay. So now, how is it going to get reflected back? It reflects back in the same, along the same path, but in the opposite direction. Say this is the direction of the incident ray. This is the direction of the reflected ray. Now, what is the kind of the image formed? See here, this ray is going like this. See, let me extend the reflected ray like this. This is the reflected ray. This is the reflected ray. So they are diverging away. As you are moving even much farther, you can see they are getting diverged away. They move away from each other. So there is no point that they converge here anywhere. So it is similar to the special case of concave mirror. Now we have to extend these dotted lines to such a point from where they seem to emerge out. From where they seem as though that they are coming from this point. So here is the virtual image formed. Here is the virtual image formed. See, in case of concave mirror, when the virtual image is formed, you have seen the image as magnified, right? Erect and virtual. Here what is that? Here this is erect image only, virtual image only, but what kind of image? Diminished image. That means image is smaller than the size of the object. Size of the image is smaller than size of the object. Can you see this one? Yes, this is how the rays seem to be diverging away from this point. Thus this point, the point where these rays are meeting, right, as though they are passing from here. So this is the location of virtual image. Smaller in size or diminished image. You'll get a smaller view of the object inside the mirror. It can't be captured anywhere on the screen. You can only see inside the mirror. Shall I give the best example for this? Rear view mirror. See, side mirror. Suppose you are traveling in a car and you can see the background, like what is there behind the car, how many vehicles are coming, like the whole road, how much wide the road is, that part, like from behind your car you can see the vehicles that are coming from behind in a very small mirror. In a small mirror you can capture such a wide field of view. That means such a big object can also be seen in a small mirror. And the kind of the image formed here is real image, okay, I'm sorry, erect image, and it is smaller in size, but it is virtual. Why we are saying it is virtual? Because we cannot capture the image on the screen, rather we can see it only in the mirror, So this is the case about convex mirror. Very important concept. You need to learn these two ray diagrams. Now let me define what is how is the image formed. So image kind is, it is virtual image, diminished, or what we call as not totally diminished but smaller in size. And what is that? Erect image. Okay, so this is the kind of the image formed, and wherever you keep this one, this is how the image is going to be. Okay, so now what are the applications of this convex mirror? Where is this convex mirror? Already we discussed just now that your side mirror or rear view mirror, where in front of the driver you will be having the rear view mirror, where through that mirror you can see what is coming from behind. So rear view mirror, side mirror, even in colonies and big apartments you can see that wherever there is a like 90-degree path, like so from that direction if a vehicle is coming to a person from here, he can't see what the vehicle is coming, whether the vehicle is coming or not. So there you can observe that there will be big huge convex mirrors located there. So that helps in viewing the objects which are coming from the other direction. Okay, so that is, it is used as view mirror, rear view mirror, and also it is used in street light reflectors. See, street light, it is not something like that, it has to focus at one point. Street light should spread to much area on the road. So therefore, whatever the light rays which are coming from the bulb are made to fall on a convex mirror, so that the light scatters in different directions, and thus it spreads out for a larger area. Thus, even in street light reflectors, we use convex mirrors. Okay children, these are the applications of convex mirrors, where we use them. These are the daily uses of convex mirror in every day-to-day life, where we use convex mirrors. Okay, done. So we are done with the convex mirror. Now let us come to the applications of concave mirror. One of the applications given in your textbook, like it can be answered as a 2-mark question, or sometimes with a diagram as 4-mark question, with the rules of like how the images are formed, right? And that is solar cooker. What is the principle of it? It uses sunlight and then boils the things, or like heat is produced, right? How the sun rays are like used for cooking purpose. See, like take this one, very highly polished, highly reflecting surfaces will be there in this, are fixed inside the concave mirror, right? This is a silvered surface. Now, right, as the rays are made to fall on it from different, like parallel to each other, parallel to the principal axis, let me draw one principal axis here. Maybe this is the principal axis. Okay, For your understanding, I am drawing this, right? Parallel to the principal axis, the rays from the sun. So in that direction it will be mounted. It will be mounted like that. So where it can capture the sun rays. So now all these rays which are incident here, you know pretty well that these will pass through only one single point, that is the focus of the mirror. So let us suppose that center of curvature is somewhere here, right? If I complete, and this is exactly at the midpoint of pole and the center of curvature, you have the focus. See, every light ray passes through this. Every light ray. After reflection, this is the point. This is F. So here if you keep the objects, if you put a paper here, it burns. This is how usually in the olden days they used to burn the ships based on this particular principle. You might have heard somewhere in the stories, right? So this is how the reflected rays focus at a particular point. That means all these converge at a point. That now the intensity of the light here is very high. So thermal radiations whichever are coming from sun are made to converge at one point. So it becomes so hot there. It becomes so hot, right? Therefore, this area is used for cooking purpose. This area is used for cooking purpose. That is the principle of solar cooker. Okay, that's the principle of solar cooker, where this is one of the applications of concave mirror. One of the applications of concave mirror. And what are the other, like daily life activities, or usually what kind of applications do we have in everyday life in using concave mirrors? ENT doctors, you know what is meant by ENT? Ear, nose, throat. That means inside the throat, if you have any infection or something, that they'll keep one mirror inside, and then they'll focus the torchlight on that part of your throat, and they'll see the reflected image there, right? So that means that helps you, that mirror helps you looking at the organ, affected part of your like throat or ear or nose. And then like nose, though you can't just imagine that you can push something inside. It is something like where you will be able to see this one, the affected part of your body with the help of the concave mirror. Even the dentist, they use you might have by this time at least once you might have gone to the dentist. So he'll be having a mirror with some steel outlining and all that. He will be putting the mirror inside your mouth, and then he looks in at the affected tooth, like by focusing the light, right? And then vehicle lights. So where vehicle lights, you see in your car headlight. If you just even now quickly after the class, you can go out and see that. So inside the car headlight, you can see that there are like some reflecting surfaces, as if it's like a diamond or a crystal or something like that. So what happens here, when the light is on inside the car, each reflecting surface again reflects it back, so that the light becomes very intense, right? The light rays will become very intense, and then you can have a strong light ray which is focused onto the road. So that is vehicle light. And then next, torch lights. See, torchlight, even torchlight, you can open the torchlight and see that there is inside a concave reflecting surface. So the concave reflecting surface will be like this, and inside it very small bulb will be there. But it gives out light as if there is a 50 watt bulb, or rather exaggeration. Okay, 30 watt bulb at least. That small bulb. How? Why? Because the light which is falling on the reflecting surfaces will reflect it, and then let it focus with much more brightness. And then next, in even satellite mirrors and all that, these are used. Concave mirrors, those come under scientific applications, but these are everyday life applications, right? So this is about concave mirror, applications of concave mirror. So with this, almost we are done with the first chapter, and we have 2 derivations that we shall see in the next class. Then we can move on to the numericals. Okay, then we can move on to the numericals. Please click on the link whichever is posted in your school group so that those who don't have textbooks in your hand can find the textbook in that particular link. You can just get on to move on to any particular page, read the content, make your own notes, try to understand what is there in the textbook, and be prepared to do the numericals. Okay children, so pause the video for a moment and please copy this diagram. So where, how, what kind of image is formed in case of convex mirror, right? See you again in the next class.